If you've ever used an iPhone, tapped on an app, swiped through photos, you've already used Swift. It's this incredible language from Apple that's basically the engine running behind the scenes in, well, so much of our digital lives.
I mean, think about it. Scrolling through your feed, checking your bank account, playing the latest game, chances are Swift is the magic making it all work. It's become this absolute giant in the world of software, especially anything and everything Apple.
But with all the programming languages already out there, you gotta wonder, right? Why would Apple go and build a whole new one from the ground up? What is it about Swift that developers just love? So to really get what makes Swift tick, we've got to break it down into three core ideas. And these aren't just, bullet points on a feature list. They're more like a whole philosophy for how to build software the right way. All right, so where did this thing even come from? Swift didn't just pop into existence overnight. Nope, it was the result of years of super secret, careful work inside Apple. So let's do a quick dive into its origin story. It all started way back in 2010. Apple knew its old language, Objective-C, was, well, getting old. So they started building its replacement. Flash forward to 2014, and boom, they unveil it to the world. But the real bombshell dropped in 2015. That's when they made Swift open source, which basically means they gave it to the world. It went from being an Apple thing to a global phenomenon. Okay, so we know its history. Now for that first big pillar, safety. And this wasn't just a nice-to-have idea. It was a direct attack on some of the most annoying, frustrating problems that have plagued programming for decades. I mean, we've all been there, right? You're in the middle of something important, and the app just dies. It crashes. It's not just annoying for us. It's a massive billion-dollar headache for the entire industry. So the engineers behind Swift thought, what if we could design a language where whole categories of these crashes are literally impossible? And that's exactly what they did. So how in the world did they pull that off? Well, they went after one of the oldest, most infamous bugs in computer science. The kind of error that happens when a program tries to use something that, well, just isn't there. They did it with this really clever idea called optionals. Okay, stick with me here. Imagine you have a box. That box might have something in it, or it might be totally empty. In programming, that empty state is called nil. Now, in a lot of languages, you can just try to open the box and use what's inside without checking first. If it's empty, crash. Swift says, nope, you are not allowed to open that box until you first prove to me you've checked if it's empty. It forces a safety check, and just like that, a whole category of crashes disappears. And this right here just shows you the genius of it. The old way was basically a roll of the dice, and a lot of times you'd get a crash. The Swift way, it builds that safety net directly into the rules of the language. It's not optional, it's required. And that is a total game changer, leading to apps that are just way, way more stable for you and me. Okay, so you might be thinking all this safety stuff must slow things down, right? Well, that's what's so incredible. It doesn't. And that brings us to our second pillar. Swift is built to be both ridiculously fast and super clear and easy to understand. And that's a really hard thing to pull off. Usually, you have to choose. You can have a language that's blazing fast, but a nightmare to read, or one that's easy to read, but kind of slow. Swift's goal was, why not have both? And when it comes to speed, Swift is an absolute beast. It's a compiled language. Now, what does that mean? It means before the app ever gets to your phone, a special program called a compiler takes the human-friendly code and translates it into raw, super optimized instructions that the computer's chip understands directly. Because all that heavy lifting is done up front, the app runs at lightning speed. Now for the other half of that promise, the expressive part, making it easy to read and write. The creators were smart. They didn't try to reinvent everything. Instead, they looked at decades of programming history. As the creator Chris Latner himself said, they basically took the best ideas from a ton of other languages: Python, Ruby, C#, you name it. And the result is code that just feels clean. It's modern. It ditches a lot of the weird, clunky stuff that made older languages so hard to pick up. And instead, it focuses on being clear and straight to the point. And hey, you don't even have to be a coder to see it. Look at this little snippet. It's pretty clear what's happening, right? We're creating a player, and that player has a name. It's almost like reading a simple sentence. That's what expressive means. It's easy to understand, and that makes it way easier to build and fix things. So, okay, we've got safe,
We've got fast and expressive, but there's a third piece to this puzzle, and it's all about what happened when Swift flew the nest, so to speak. This is our third pillar, the massive open source universe it created. You see, that move back in 2015 to make Swift open source, that was huge. It completely changed the game. Suddenly, it wasn't just Apple's language anymore. It belonged to everyone. Anybody, anywhere in the world could use it, help improve it, and take it to places Apple never even dreamed of. And boy, did they ever. Of course, it's still the #1 language for iPhones and Macs, but now it runs on Linux servers. It runs on Windows machines. There are even passionate communities working to get it running on Android and inside your web browser. Swift has officially broken out of the walled garden.
And here's the cool thing that happens. When a language can run everywhere, people start building everything with it. This massive expansion onto new platforms created a snowball effect, leading to this incredible boom in tools and resources for developers.
I mean, the ecosystem today is just gigantic. You've got web frameworks like Vapor that let you build the back end of a website entirely in Swift. There are deep hooks into machine learning and AI. You're not just stuck in one editor either. And you've got powerful tools to manage all your projects. It's not a new kid on the block anymore. It's a fully mature, thriving universe of technology. So we've covered the history, we've walked through the 3 pillars, which brings us to the big question, right? Where does Swift go from here? When you really strip it all back, it comes down to those 3 core ideas we talked about: safe, fast, expressive. It's a language designed from day one to prevent common errors, to run with incredible speed, and to be a joy to read and write. And that leaves us with a really fascinating thought to chew on. Think about it. Our world runs on software more than ever. Our phones, our cars, the power grid, everything. The stakes for when that software fails are getting higher and higher. So is it possible that Swift's intense focus on safety isn't just a cool feature, but maybe, just maybe, it's the blueprint for how all programming languages will have to be built in the future? It's a big question, and I guess only time will tell.